Good morning, everyone. I've got about a 20-minute PowerPoint presentation that I want to share with you about how the Cotton app works. Some of you have already been exposed to this from working with the AgWet project in 2017. But we've made some significant improvements to the app over the winter, and I just want to show you how it runs. And I'd encourage everybody to, if they have questions, just to interrupt if they want to, or maybe chat, send you a chat. And if you can moderate the chat and interrupt me when that one comes in so that I can, not be distracted, that'd be great.
No problem.
All right, so I'm going to try and share my screen, and let's see if that's going to work. Okay, so can you see a PowerPoint presentation at this point?
You're good.
Okay, so on the first slide here, I have a bunch of names. These are all the people that have worked on getting this app working over the past 5 years. And the most important person is Jose Andres. He's the programmer of the app. He's the guy that maintains the system. So those of us that will be working with him this summer will get to know him pretty well if we run into problems, which hopefully we won't. We're all interested in cotton irrigation because there's a lot of work that's been done over the years that shows that it's not only important to irrigate cotton when we need to apply water, but the timing is very, very crucial. And that's what the AgWet project and these other projects that we're doing are all about, trying to understand when we should be putting the water on. And you can see here some work that was done in Tennessee. This was all irrigated cotton, but just irrigating at the wrong time can really have an adverse effect on yield. So we want to try and avoid that by using smarter tools. So let's move on into the app now. And so here are some of the design criteria when we did this. So the three things at the bottom are really important to us. So we want to have minimum user input. In other words, created a tool that you don't have to deal with every day. It sends you notifications when things need to be done. And it's supposed to be user-friendly, engaging, and not static. So we'll see about that. The concept behind the Cotton app is a very well-researched concept. It's not something we developed. It's a soil water balance model that uses evapotranspiration as the key. So if you look at this picture here, you see these diagrams that show how simple it is in concept. Essentially what we have is, if you can imagine the very left item here, this could be a pot. So the area that's in blue could be the pot that has a cotton plant growing in it. And at the beginning of the growing season, the pot has all the moisture that we need in the soil. As the plant grows and starts using that water through evapotranspiration, the soil moisture decreases. The way we replenish the soil moisture is either through rain or through irrigation. So basically what we're doing is we're keeping a daily balance of the available water in the soil profile by subtracting crop water use by evapotranspiration and then adding any rain and irrigation. So it's generally been accepted by people who do irrigation scheduling that once you have depleted about 50% of your plant available water in your soil, that's not 50% of all the water in the soil, but 50% of the plant available water, then you should trigger irrigation. If you get to something like 75% deficit, you really are beginning to stress the plant, and it's at the point where you really can't catch up anymore. So you may be able to irrigate and keep the plant going, but you can't catch up and bring the soil profile back to good condition. So how do we calculate this critical evapotranspiration by the crop? We do it by using this equation that you see here. The equation has two variables. One is ETO, which is the theoretical evapotranspiration, and the other one is the crop coefficient. So the principle here is you measure theoretical evapotranspiration, or you calculate it somehow. So this can be done with an evaporation pan or by using weather data, which I'll show you in a minute. And then you multiply that theoretical evapotranspiration by a crop coefficient, which is a factor that tells you how much of that theoretical evapotranspiration the crop is using every day during its life cycle. So this would be a daily number. So this stuff is, as I told you, well understood and used worldwide. The first sort of worldwide publication that described this was published by the Food and Agricultural Organization as far back as 1977. Most recently, it was updated by a very well-known faculty member at Utah State University, Richard Allen. So this is the 1998 update called FAO 56. And many people use this as a short, as an abbreviation for the concepts I just described. So when you say I'm scheduling using FAO 56, it means using the concepts I just explained. So how do we calculate evapotranspiration, the theoretical evapotranspiration, which we need here to multiply by the crop coefficient? So the equation for it is quite complicated, as you see here. This is called the Penman-Monteith reference ET, as described in FAO 56. A lot of the variables in the equation actually are the results of other equations, but more or less you use a bunch of weather data, so temperature, solar radiation, wind speed, and things like that, to calculate the theoretical evapotranspiration. And we can do that by pulling data from the Georgia weather stations that we have. So all our weather stations are equipped to provide all the data we need for calculating evapotranspiration. And if you go to the weather station sites, they actually give you evapotranspiration measurement. They don't calculate it exactly using this equation, but the numbers are very, very close. Another option that has become recently available is that the National Weather Service is producing every hour a forecast of evapotranspiration across the continental United States. So you can go to this website, you can search for it, it's called the Forecast Reference ET tool. You'll see a map like this of the US that I show on the left side of the slide. Each of these little numbers are the forecast of evapotranspiration for that particular area. And it's also color-coded. So this was for yesterday afternoon. You can zoom in and you can find our area. So here is what was going on in Tifton yesterday. You can actually click on a specific location and a box will pop up that'll give you the daily forecast, the weekly forecast, and a graph of the trends. So what we've been able to do is write some code that takes the coordinates of your field and queries this website and returns the forecast ET. So we have two ways to calculate ET in Georgia. One, we can use our weather stations and use that formula that I showed you on the previous slide. Or number two, we can go to the NOAA site, the National Weather Service site, and query your field and pull up the forecast ET. So the forecast ET is not a measured ET, but when we compare the two, they're actually quite close. So I feel that either one is a pretty good value. Does anyone have any questions about what I've covered so far, especially about how we get the ET values? Because it's a pretty important parameter for the app.
Any questions so far for George? Okay.
Okay, no questions. All right, we'll move on. So if you think of something, just go ahead and send it in the chat window and we'll answer it as we go along. Okay, so I've covered how we calculate theoretical evapotranspiration. And I told you that we need this thing called the crop coefficient in order to calculate the actual plant evapotranspiration. So the crop coefficient is a really tough thing for us to get a good handle on. But there's a lot of good work that's been done in the Southeast. And what I show you here on the right is a graph that shows the crop coefficient curve for cotton that we're using in our app. So if you look at the graph, we have, let's look at the bottom axis first. So on the bottom axis, we have growing degree days or accumulated heat units. All of you know that the physiology of cotton is driven by the accumulation of heat units. So if you've got a really hot week, the cotton is going to grow faster than if you have a cool, cloudy week. And so as the accumulated heat units grow across the growing season, the plant goes from emergence to first square to first flower and first open boll and so on. What the curve shows us is that as we go from one stage to the other, the plant is using more and more water up until we reach a peak right after first flower. So if you look at the numbers on the y-axis, you can see that the crop coefficient here at some point reaches 1. When we multiply the theoretical evapotranspiration by 1, that means that the plant is using as much water as we're calculating with the theoretical evapotranspiration. Once we exceed 1, it means that the plant is actually using more water than we calculated from our theoretical evapotranspiration. Obviously, as you all know, during peak bloom and when the bolls are beginning to fill is when we need to make sure that we're watering cotton the most. So all these, this curve was generated by some work that was done both here in Georgia by our previous cotton physiologists, Glenn Ritchie and Craig Bednar. So they developed a very nice table in this top left document that tells us how many growing degree days we need to go from the different phenological stages of the cotton. And then Calvin Perry led another study that was funded by Cotton Incorporated that summarized the work that was done all across the Southeast about crop coefficient curves. So the one I'm using in the app is a compilation of all the Southeastern curves that were developed. And we tested this over time, and we fine-tuned it, and now we have a curve that I think works pretty well. But the critical part of this curve is that it uses accumulated growing degree days. And that really keeps us on track, because if you're using days after planting and you have weird weather phenomena, you could get out of whack pretty quickly in terms of predicting where your physiology is. Generally, days after planting works on average, but if you have a really cool year, things slow down quite a bit. So those are the three factors. Now, we've built this app so that it also can work across the cotton belt. It's not just good in Georgia. You can use it all across the cotton belt of the U.S. So we have a number of regional crop coefficient curves. So if you're in Texas, there's a specific curve for Texas. If you're in Arizona, there's a specific curve for Arizona, and so on. But that really doesn't matter to us today. So if you remember, one of my very first comments was that we're using a soil-water balance model, and rain is one of the key parameters that we need to measure so that our model is accurate. If our rain is off, if our estimates of rain are off, the model is not going to perform well. And those of you that used the app in 2017 appreciate what I'm talking about, because we had some challenges with our weather data. So to maintain flexibility and make sure that we're not reliant on just one weather data source, we have programmed the app now to be able to use a variety of weather data sources. So it can either use our Georgia Weather Network, it also uses the Florida Weather Network, or it can use national data sets that provide rain and precipitation. We experimented with a number of sources for these data, and we've settled on a company called Dark Sky. And you can see the URL at the bottom right of the picture, but they produce on an hourly basis an estimate of rain and temperature for the entire United States on a 2-kilometer grid. So again, when we have your field coordinates, we can go to their database and pull out the estimate of rain and the estimates of temperature for that particular field from that grid. And we need temperature to calculate growing degree days, and obviously we need rain to run the soil water balance. And Dark Sky is just a really cool website. I spend a lot of time when I'm taking breaks just going to their website and looking at things. So the map I'm showing you here has nothing to do with our app, but it's so cool because yesterday at 6 p.m. or so, when I was working on this presentation, I just went to their website and looked at what the worldwide temperatures were for that particular time. And you can see here this color-coded image. You can see the cold fronts moving through. It's just a cool thing to look at. So if you have some time, I'd encourage you just to go visit Dark Sky and take a look at what they have. It's pretty cool. Okay, so at this point, I want to transition from telling you sort of the background of how the app works to actually showing you physically how it works on a smartphone platform. So again, I want to pause for a moment and see if anybody has any questions. Wade, have you received any chat questions?
No, I have not.
Okay. Anybody have any questions?
Anybody have any questions?
Okay, so we'll proceed. The app is now in the app stores, so you can search for SmartIrrigation Cotton, either in Google Play or on the Apple Store, and it's downloadable. Downloads in about 5 seconds. It's completely without cost at the moment. Once you download it, you'll have an icon that looks like the one I've got highlighted in the yellow box here. Okay. So if you open the app, then you can begin the process. So we'll go through this step by step just to show you what it entails. If you already have used it, so if you're a past user and you open it up, you'll see that the front page this year is a little bit different. So you'll see a list of all the fields you might have had from last year that you had registered, or if you've already registered fields this year, you'll see them. If you are a first-time user and you open the app for the first time, what you'll see is this screen, which is the screen that allows you to locate your field. So the app uses the coordinates of your phone where you currently are. So if you have your GPS enabled, it'll identify where you are, and then it will drop a pin at your current location, and then you can drag that pin to where your field is. So you have two options. One, you can look at it from the map view like this that shows streets, or you can select satellite by touching the bottom right-hand button, and then you can also see satellite view, which might be easier to identify a specific field than just the road network. So that's a new feature for this year as well. So once you've dragged that pin and dropped it to where you want, you just tap it, and then you go into the process of providing some information about your field. The first thing you have to do is you have to name the field, provide any name. So it's good to not call it just field 1, field 2, field 3, because those are sometimes difficult to remember. Just name the field whatever is a good identifying feature. It's very important to get the app up and running at planting. Now, this year we have built in the feature, upon request from some of the agents last year, of being able to start the field up a few days late and back calculating. But we can only back calculate if you are using the Georgia Weather Network data. And I'll talk about how we select that in just a moment. Because we have a limited number of stations and we're archiving all their data so we can go back and calculate the data from your closest weather station. If you are outside of Georgia or you have selected to use the national data sets, well, we have no idea where your field might be, so we're not archiving those data. And so that's not possible to backdate. But there's a trick here. You can select the closest weather station to you to get it started, and then you can select the national gridded data, which I'll show you how to do in a minute, to continue onward. So if you don't get around to doing it on the first day as you plant, there is a way to get around that now. And if you need more information about that going down the road, if you want to use the app, just call me and I'll explain it to you. So you select the planting date, and then you have to select your weather data source. As I mentioned before, we have two options, right? You can select one of the weather stations. So the app automatically identifies the weather station that's closest to you. So I was doing this, of course, in Tifton yesterday. The closest weather station to me was 1 mile away. That's the one it automatically selects. But if I don't want to use that one, for example, I know it's down, it's not working, I can pick whichever of these other ones that are close by that I want. Or I can select to use National Weather Data Grid. There you don't have any other options. Everything's automated. We're using the coordinates of your field to find the data for you. Okay? So this is a pretty important point. You can go back and forth between these things at any time. Doesn't cause you any problems. So you can fool around with that. If the weather station goes down that you're using and you want to continue working with the app, we're going to automatically go to the National Weather Data Grid and get the ET data for you, but we're not going to automatically update rain unless you tell us to by selecting this option. Okay?
George, you got a question in the chat box.
Okay, good.
Okay, it says, this is from Brenda. It says, what if you have a weather station at the field?
Okay, Brenda, excellent question. There is a way for you to update the data manually, and I'll show you that in just a minute. So keep that thought ready, and I'll answer that in a minute because there is a way to do that. Okay, the next step in setting up your field is to select the soil type. Now, remember, we're doing a soil-water balance model, so it's pretty important to get a pretty good assessment of the soil type. Again, if in Georgia, we're almost all going to be in loamy sands or sandy loams. One of those two, if you find that you've picked a particular soil type and it's not really working out, it looks like, it's staying wetter than you think or it's getting drier than you think, you can switch at any time. You can edit the field at any point and switch to a different soil type at any time. And it'll recalculate for you. So it's pretty flexible there. And then the final thing that we have to do before we're done setting up the field is we have to select the kind of irrigation system we're using and tell it what our default irrigation amount is. So the reason we have 3 different types of irrigation systems listed here is because the efficiency of the systems are different. A drip system obviously is more efficient than a low pressure overhead sprinkler system, which is more efficient than an overhead high pressure system. So that determines how much of the irrigation water you apply actually makes it to the root zone. So we have an efficiency factor built in. The default rate here is to make it easy on you. So if you're always putting on 1/2 inch or 3/4 of an inch, you can adjust that here. And so that when you tell the app in a few steps from now, oh, I irrigated my field, it'll automatically applies that default rate, but you can also change that rate at any time. It's very easy to change. Okay, so now you're done. You've set up your field. That whole process should take you no more than 3 or 4 minutes. So it's pretty easy to set up. You see the parameters you've selected here. This is the main operator screen of the field, of each field that you're using. So it tells you all your options here. If you don't like any of these options, you touch this edit field button and you go back and you change any of those options. I'm going to discuss these other features here in a few minutes, so I'm not going to talk about them now. So these are the effectiveness factors that I described earlier for the different irrigation systems, and that's why we're using, we ask you to do that. Another thing that you should be aware of is that our profile is growing every day until we reach a maximum of 30 inches based on how we estimate the roots to be growing. So we start with a minimum root depth of 6 inches. So the first day, we calculate our available water content on 6 inches. And then every day after that, we add 0.3 inches to the depth of our soil profile until we reach 30 inches, and then we're done. We say our root doesn't grow below 30 inches. And that's just an assumption we had to make. Seems to work pretty well for most conditions. When we begin, we assume that you don't have a water deficit. So you'll see this, and then from day 1 or 2 onwards, as evapotranspiration starts to play a role, then you'll start to see a deficit increase, which I'll explain in a few minutes. Okay, so now you've got your field set up and the app is running. And to make it easy on the users, essentially what we're doing is we're sending notifications to you whenever an action is required, or when you've had rain in your field, or when the phenology has changed. So when you've gone from emergence to first flower, or from first flower to first square, or excuse me, from emergence to first square to first flower, and so on. So what I'm indicating here is that I've got all these fields set up in my app. I've been testing it for several weeks now. It's giving me a notification that the water deficit in Homestead, which is a site in Florida that I'm testing, is 42%, and irrigation is recommended. So that's what it's sending you. Now it's up to you to decide whether you want to irrigate. It's not going to tell you to irrigate. It just says recommend irrigation. So at that point, you want to take some action. You open your app. You see your fields here. Now you see the Homestead field. So it's showing me this 42% deficit that I just talked about. So this little bar here is an interactive tool that shows you basically what your deficit is, so visually. And then this also calculates, you see the number says 0.47 inches. That's how much water you have to add to the profile to bring it back up to capacity, to full capacity, okay? And a quick way, so if you just want to check every day what's going on in all your fields, you can open up the app and just look at these little bars here. These bars are the same thing that you'll see on the user page of each field. So you can get a quick summary. Oh, look, everything looks pretty good. We must have had some rain all over the place. I don't have to worry about any of my fields today. Okay, so this 42% represents how much of the plant available water has been used. We start sending notifications at 40% to give you time to prepare for irrigation. The recommended irrigation threshold is 50%. So you start getting notifications at 40% so you can prepare to irrigate if you want. Another nice feature is that we have this thing that I've highlighted in yellow now at the middle of the screen. You can take your finger and swipe across this region. You can go back and see the data for the past 10 days. So this moves forward in a 10-day window. So you can always go back and see what's happened for the past 10 days. So you'll see exactly what I show you here, but for every day of the past day. So if you scroll back here, you'll see the previous day, the deficit might have been at 39, the day before that at 36, and so on. Okay. So now you decide to irrigate. Okay, so we see our deficits of 42%. I'll go ahead and irrigate. So I tap this button here that says Add Irrigation, which means I irrigated my default amount. Irrigation applied. You see here on the next screen, there's the icon changes. It shows you that you've irrigated, and now it shows you in a lighter blue that you've added water back into your soil profile. So the profile now is full. You don't have any deficit. You're at 2%. And it shows you how much irrigation was applied, 1/2 inch. That was your default. If you change your mind and say, no, I didn't really irrigate it, I hit that by mistake, you can tap here, remove irrigation, and that number's gone. If you want to change how much you've applied, you can tap See Details, and you can tap See Details, and then you can see the amount. You see that the effective amount is 0.45, and you can change how much you applied. So if you decided to apply an inch instead of the default 1/2 inch, you change it right here. Okay. So this is when you tap the See Details screen, you see a lot of what the background information about what's driving the model. You see what the daily evapotranspiration is. You see how much you've accumulated over the past 7 days. You see what your rooting depth is at this particular time. So this is all the background information in the app. Okay, so you're also getting notifications about rain. So Brenda, did I answer your question? No, I'm about to answer your question about the rain. Okay. So here's the cool part. So you get a notification that you've received rain in your field. You go to the user page, you see there's a little rain icon. You see it again, how much rain has affected your soil profile. There's a slight blue tinge up there. In this particular field, we were wet already. I'm not sure what Callum Perry's doing at Stripling this year, but we're getting 2.5, 3 inch rains every other week there. So rain observed 2.5 inches. Okay. However, this is a very important thing for you to remember. I've designed the app so that the maximum daily rainfall that it can accept towards the soil water balance is 1 inch per day. Because if we get much more than that in any of our soils, really, our soil profile is already full, or we're going to lose it as runoff if we have a really intense rain. So you can see here we received 2.5 inches. Only one of that inch is going to be used towards the soil water balance. And of course, we don't build water up. Once we get to 100% capacity, it just stays there. We've also noticed that by using soil moisture sensors that if we get less than 0.15 inches, we really don't register that moisture in the soil profile. It kind of gets on the surface, dries off, and the plant roots never see it. So if we get less than 0.15 inches in a day, we discount that as well. So the operating range is between 0.15 inches and 1 inch. Okay. So, okay, I'm sorry, I'm going to back up. So Brenda, if you have your own rain gauge in your field and you are not satisfied with the information that's coming either from the national data or from the Georgia Weather Station network, then you can go tap the See Details screen, and then you can adjust the rainfall amount. So you can add rain, you can subtract rain. So if the automatic amount of rain that's come in is 2.5 inches and you say, no, I only got 1.5 inches, you can change it here at any time. So we have had a long and hard debate about how do we bring in automated rain gauges that users might have in their own fields. Until we come to some kind of agreement that we're going to support as a state X brands of weather stations, it's going to be impossible for me as a programmer to go to every company's website and pull the data for a particular user. So if we say we're going to support 5 brands, then I can build APIs to go to those fields and to go to those companies' websites and download data from individual weather stations that farmers or users might have. But I can't go randomly to all these websites. So if you have a good weather station in your field, or you have just a tipping bucket rain gauge, you can update the data here. And you can do it retroactively too for a few days, and the balance updates. Okay, so one final type of notification we get when the phenological stage changes, you get a notification, but you can also always check the phenology at the bottom of the user screen. So you'll see a bar down here, and it tells you where we are in terms of accumulated growing degree days, and it shows you physically where we are in terms of the phenology. So I was very, very afraid the last few years that with the new varieties, this would get completely out of whack, but actually it works quite well. It seems to be that the prediction by the model is always just 1 or 2 to 3 days off at most, except when we start getting to open bowls. And then it starts to fall apart a little bit. We can be as many as 4 or 5 days off when we're predicting first open bowl. But, you know, it's really not critical for irrigation at that point, so I'm not too worried about it. Yeah, it's already covered the rooting depth. So a couple more features, and then I'm done talking about how the app works. On the user page, we have 2 little icons at the top that are new this year. The first one that I've got highlighted there, if you touch that, it takes you to the forecast screen. So this is a weather forecast from dark sky. And it gives you 2 options. You can see the current conditions. You can see what the forecast is for the next few hours. And then you can also see what the forecast is for the next few days. So if the app is asking for or recommending irrigation, you can look at the forecast and see, okay, is rain anticipated? Maybe I can hold off on irrigation a day or 2. The final feature I want to show you is this little button up here at the top right that has you know, the next action that we're all used to now from using our phones. And if you press that, what we'll do is we'll email you to the user email that you've registered with the app, a spreadsheet, an Excel spreadsheet that has all the data from the day you started the app until the current time that you've downloaded it. So you can go in there and you can see a complete record of all the metrics that we're using to run the app. This was a request we had last year, particularly from Jennifer Miller. She wanted to see what was going on, so we put this feature in. So you'll get this Excel spreadsheet. You'll see all the calculations. There are no secrets. You can do this every day if you want to. You'll get an updated one that has 1 more line of data in it every day. So I've got 2 more slides to sort of summarize the performance of the app, but I'd like to pause again to see if anyone has any questions about how we actually use the tool itself.
Dr. Vellidis, I got one again from Brenda, and it's about soil type. It says, could you input your soil type? What if you have a heavy soil rather than a sandy soil? I guess I go back to that, to what you...
Yeah, I don't want to go back to all those slides again, but we have 7 generic soil types there, exactly, ranging from fine sand to clay. So that's the options you have.
Right.
So if they don't represent, if you choose one and it doesn't represent your soil type very well to start with, then you can change to a different soil type in there. But we couldn't have an infinite range of soil types.
That's right.
So we're thinking about allowing the user to put in the available water holding capacity of their soil, but we're thinking that a typical farmer really won't know that information. For researchers, we might make that option available in the future. But Brenda, that's the limitation. You can choose between 7 soil types. Okay, so this second to last slide shows you the evaluation we've done of the cotton app at the Stripling Irrigation Research Park that Calvin Perry runs at near Camilla. And so for the past 5 years, we've done trials there where we've compared the performance of the cotton app to soil moisture sensors. So these are the same kind of soil moisture sensors we're using in the Ag Wet project, our extension checkbook method, and then rain-fed plots. So every year we have those 4 treatments. And then you can see the yields of each one of the treatments in pounds per acre and lint yield. You can see how much irrigation water was applied from each treatment. The rain feds always have some rain because we always apply some after planting to make sure we have good germination if it's not if we don't get a small rain. The irrigation water use efficiency category is interesting. So this is the amount of yield produced for every inch of irrigation water applied. And it's interesting that in many years, we have negative numbers there. And the negative number indicates that our irrigated treatments actually produced lower yields than our rain-fed treatments. So as smart as we think we are, we really aren't smarter than Mother Nature in some cases. But anyway, the bottom line is that it's pretty even in terms of years that the app outperforms the sensors, or the sensors outperform the app. So we have 2 years that the cotton app did much better than the sensors. We have 2 years when the sensors did much better than the app. And then we have 2013 when the yields were almost the same. And it's always better, no matter what whether you're using the app or the sensors, you're almost always better than the checkbook method. The checkbook method, I am convinced, is over-applying water. And the main reason it's doing that is it's counting days after planting and not taking into account the environmental conditions. So the app performs pretty well, I think. And then I've got this final slide here that sort of tries to compare the advantages and disadvantages of using either sensors or ET models. I work with both tools. You know, I've spent 10 years developing a sensor system. I've spent 5 years developing the app. We're providing a range of tools to potential users because we think there's a place for all of them. But they both have some advantages. So let me run through them real quick. So the ET models, like the app, their main advantage is that they're very low cost. Their big disadvantage is that they require accurate weather data to run well. If you don't have accurate weather data, you might as well not run it. So I'm really, when people want to use the app now and they're not right next to a weather station, I'm really recommending that they invest in an automated rain gauge, the one that sends data to somebody's website that they can check every day and update the app if the app gets off. Otherwise, I don't know that you have assurance that the ET models, regardless of whether it's the app or some other model, are working well. And you do have to characterize the soil, so Brenda's question here is valid. Okay, now sensors, their big advantage is that they're measuring the soil directly, right? They have a higher cost, they require installation and removing, but I think their biggest disadvantage is none of the two previous bullet points. Their biggest disadvantage is that they're a point measurement. So when you install a sensor, basically you're measuring a 2-inch radius around that point that you've installed the sensor. You're not measuring the whole field. And I want you to take a look at these 3 graphs. So these are 3 plots from Stripling Irrigation Park. They were all three were rain-fed plots. And if you look at the diagram at the bottom right, you can see these plots were no more than a couple of 100 feet apart from each other. Okay, so uniform soil. The lines in the graphs show the soil water tension. So 0 is wet, 200 is very dry. So as the lines go upwards, it's indicating very dry conditions. So you might expect that a rain-fed plot would be mostly dry. So you see in node 36, we have pretty dry conditions. In node 35, we have pretty dry conditions for most of the year. But in node 43, which is this plot here, so the top right in the plot diagram, we have relatively wet conditions for most of the year, and then it shows drying out at the end. So what's going on here? These plots were not irrigated. They were all rain-fed. The point is the sensors are measuring a very small point in the field. So we could have put this node, this soil moisture sensor, next to a plant that didn't have much vigor. So you see that the response is very different. So I caution those of you that think that you put 1 sensor, 2 sensors in the field, you're characterizing the whole field. Be very careful about locating the sensors. So that's the weakness of the sensor systems. The weakness of the ET models are that they need really accurate weather data, otherwise they fail. And Wade, at that point, I'm done with the presentation. And if we have a few minutes, I'd be more than glad to answer any questions participants might have.
We do have a few minutes. Is there any questions from the group for Dr. Vellidis? And while you're thinking of your questions, I just want to encourage you to use the app and get with farmers and try to educate them on it. Pick 1 or 2 farmers and see if you can try to get them to adapt it. There's plenty of room for growth with this thing and use.
Yeah, and if anybody has any questions, I mean, you can call me at any time. And we hope we really won't have any technical issues this year. We've changed our support to Jose. he's on it 24/7, and we really get very good support from him. So I don't expect any technical difficulties.